All right, we're going to go ahead and start this homework here for 2.6. So the instructions here, consider the following equation and find y using implicit differentiation. So remember, implicit differentiation is used when it is difficult or sometimes impossible to solve the equation for y. So we have 2x squared minus y squared equals 6. So what we're going to do is we're going to differentiate this, treating x like our variable. And the reason why we know that is because they say find y prime. Whenever we say find y prime, we will assume that the other variable in the problem, which is x, is the independent variable, so that's what we will differentiate with respect to. So on both sides of the equation, I want to know what the derivative with respect to x is. So it's almost like you're operating on each side of the equation separately. So let's start off on the left side. This derivative is the derivative of two terms, so it's almost like you can distribute that derivative through. So I want the derivative with respect to x of 2x squared minus the derivative with respect to x of y squared. And then on the other side of the equation, I put equals the derivative with respect to x of 6. Now, 6 is a constant, so derivative of a constant is always 0, so I'm just going to go ahead and do that side right now. All right, now on the first term here, if I'm going to take derivative with respect to x of 2x squared, that's just our traditional derivative the way we've always done it. The 2 will come down in front. It'll multiply times the other 2 will become 4. The power on x comes down by 1, so we have just 4x. Now on the other one, though, we're trying to take derivative with respect to x of y squared. So what we want to do is pay attention to the chain rule. So I'm just going to write a little something here on the outside. Let's say I have something squared, and I want to take the derivative of it. The derivative of that will be equal to 2 times whatever that something was to the first power. So that's the power rule. But then chain rule says times the derivative of what was in there. So if we're treating the base of this is like a box. If we have a box squared, the derivative will be 2 times the box to the first power times the derivative of the box. So for us in our problem, our box is actually the y. So what is the derivative of y squared? Well, derivative of y squared will be 2y, but then times the derivative of y itself. And the derivative of y is not 1 because we're differentiating with respect to x. So the derivative of y with respect to x is actually y prime, which is exactly what we're looking for in the problem. And so we're done with chain rule, and then we have the other side of the equation. And now all we have to do is isolate the y prime term. So I'm going to, let's move the negative 2y y prime to the other side of the equation. And then let's divide both sides by 2y. So y prime is equal to 4x over 2y. So at this point, what we need to do is try and see if there's a way that we can simplify this or clean this up, because we'd like our derivative to be in terms of x only. So is there a way in this problem to try and solve this thing for y? So how about this? 2x squared minus 6 equals y squared. That's moving the y squared to the other side, moving the 6 to the left side. And now take the square root. So this gives us plus or minus, sorry, I'm going to move the y. Let's see. Y is equal to plus or minus, we're taking square root on both sides, square root of 2x squared minus 6. And that's what I can replace this y with right here. And so what we get for the first problem, part A, is that y prime is equal to, I could have just done that, cancel those 2's out, 2x over just y, but y is plus or minus the square root of 2x squared minus 6. So as you can see, our derivative can be really two things. It can be this expression if we have the plus, or this expression with the minus, one or the other. Now in part B of this problem, what they want you to do is they want you to solve for y before you take the derivative, and then figure out what the derivative is. So what we would have done is we would have first solved for y, which would have given us this And that came from this right here. Now differentiate. So derivative of this is plus or minus. Okay, now the derivative of the square root of something, we have chain rule here. Derivative of square root of something is 1 over 2 times the square root of that something. Then chain rule says times derivative of what was inside. The inside is this. So derivative of 2x squared minus 6 with respect to x is 4x. Then you can see the 4 and the 2, this reduces down. You get basically plus or minus 2 over, I'm sorry, not 2, 2x over square root 2x squared minus 6. And you can see here that the answers match. Okay, either way you do it, you get the same result. So that's just to show you in that problem that either way you do it, you'll get the same answer. Now you do have to be careful because sometimes you cannot solve for y, so you couldn't check it this way. All right, let's take a look at this one here. All right, so again, we want to find dy dx. So in other words, we want to find y prime. So we're differentiating with respect to x. If I differentiate with respect to x, 8x cubed plus x squared y minus xy cubed. And then the other side, differentiate with respect to x, the constant 9. So what I'll do here is I'll differentiate each of these 3 terms one by one. And then on the right side, derivative of constant is 0. I'm just going to put that down here already. All right, what is the derivative of 8x cubed with respect to x? Well, that's just going to be 24x squared. So that's this. And now notice on this one, this is important. We have x squared y here. That's a product right there. So we're going to need to apply the product rule. So I'm going to say plus because I had a plus there. And now derivative of product. So this is like our f, this is like our g, and we apply product rule. Derivative of f. So what's the derivative of x squared with respect to x? That's just 2x. Product rule says then times g, which is y. Plus, product rule now says derivative of g. So what is the derivative of y? Well, the derivative of y here is y prime because we're treating y as the dependent variable. So we do not say 1 here. Then times f, which is x squared. So that's just that middle part. And then we have to look at minus whatever the derivative of this last term is. And again, we have product rule right here. So this is like our f and this is like our g. So let's see how we're going to deal with this. I'm going to put the minus sign here. I'm going to put set of parentheses because I have to do product rule. So derivative of f, in this case, derivative of x is 1 because we're differentiating with respect to x, times g, which is y cubed, plus the derivative of g. So be careful here because this is like a box cubed. The derivative of box cubed is 3 times that box squared, but then times the derivative of the box itself, so derivative of y, which is y prime. And then to finish off the product rule, we have f, which would be x. And then close that all off, and then remember we had equals 0 over here. So we'll try and clean this up now. We have 24x squared. We have plus 2xy. We have plus y prime x squared, and then I'll distribute the minus sign through here. Minus y cubed minus 3y prime y squared. 3y prime xy squared equals 0. All right, so we have taken the derivative. What we want to do now is we want to try and at least get all our y primes together and isolate the y prime. So everything that has a y prime, I will just leave on one side of the equation. 3y prime xy squared. And everything that did not have a y prime, which is this, I will move to the other side of the equation. So I'm going to make it this, y cubed minus 24x squared minus 2xy. And now on the left side of the equation, since these both have y primes in it, I can factor out a y prime, be left with x squared minus 3xy squared equals y cubed minus 24x squared minus 2xy. And then to get y prime by itself, I will divide both sides by this. So we get y prime equals y cubed minus 24x squared minus 2xy all over x squared minus 3xy squared. And that should be my derivative. Now, it would be very difficult here for us to solve for y in this equation, so we'll just leave our answer like that. So in order to know what the derivative is, you actually have to know what both x and y are. So you would have to have an actual point on the curve in order for you to know the slope of the tangent line. So you'd have to know both the x and y coordinate. Very important there. All right, quick little break here. Okay, let's take a look at number 3. Oh, you know what? I forgot to show you the, here it is, 2.6. Here was the one. Take a look at what they've got here. Right here. So the order of things might be a little bit different, but that looks like, just double checking everything. Yeah, it's right. Okay, so that's the same answer they got. Okay, number 3. So for number 3, again, we cannot isolate y easily. So what I like to do here is I like to stop using the the d dx thing from up here. I kind of stop using that. So I just start taking the derivative mentally. So what is the derivative of 8x squared with respect to x? Well, that's just going to be 16x. Then I have plus. Now here's a constant. Well, you know what? I'll leave the constant there. I'm going to split this right down the middle. That's a product rule. My f is 5x. My g is y. So derivative of a product is the derivative of f. So derivative of 5x is 5 times g plus the derivative of g, which means derivative of y. So I'm going to say y prime times f, which is 5x. So that takes care of the middle term. And then I have minus the derivative of y squared. Again, y is our dependent variable, so this is going to be 2y, and then chain rule, derivative of y inside is y prime. Then equals the constant, take derivative of constant on the other side, you get 0. So here's where I am. I've got 16x plus 5y, 5y plus y, I'll say 5y prime x minus 2y prime y equals 0. Now I have two terms that have y primes in them, these two. So I'm going to take the other two to the other side. So I'm going to subtract those on both sides. So I have 5y prime x minus 2y prime y equals negative 16x minus 5y. I'll factor a y prime out. On the left side, and then I will divide through by this right here. So negative 16x minus 5y all over 5x minus 2y. And again, that should be my derivative. That's the slope of the tangent line. But again, in order to know what the slope is, I need both the x and y coordinate. So I need to know like a point on this curve. Which one we just do? This one? So let's see how ours looks a little different. Notice that they have positive, positive here, and on the bottom, 2y minus 5x. And here I have negative, negative, and then positive 5x, negative 2y. You can imagine just factoring a negative out of the top here, and then moving that negative to the bottom, and then distributing it through, and that would match exactly what they had. So we got the same answer. Okay, let's see if I can work through this one here. Give myself a little room there. All right. So I'm going to take derivative of this. Okay, here we go. Notice on the left side, I have a product here. Right there, there's a product. So this is like my f, this is my g. So what is the derivative of f with respect to x? Well, what's the derivative of y with respect to x? It's y prime times g, which is cosine x. Product rule then says plus the derivative of g. Well, derivative of g with respect to x is just negative sine x. And then times f, finishing off the product rule, which is just g. That's the derivative left side, equals the right side. Derivative of 3x squared by itself is just 6x. Then plus the derivative of 2y squared is going to be 4y. Chain rule says then times y prime. So we notice that we have two terms that have y primes in them, this one and this one. I need to get those together on one side of the equation. So I'm going to say y prime cosine x. Bring that other one over, so negative 4y prime y. Then on the right side, I still had that 6x, but then I needed to move this one over. And it's negative on the left side, so it'll become positive on the right side. And I'll put the y in front of the sine x. And now factor out the y prime on the left side. You kind of get the idea that this kind of, you have the same pattern of things here after a while. You always take the derivative implicitly, and then you find all your y primes, get them on one side of the equation, and then you factor out y prime, and then you divide through by with what's left. Okay, there we go. So let's check this. Oh, you know what? I think the answer was there. Yeah, it's right here. 6x plus y sine x over cosine x minus 4y. Oh, this one's a little interesting here. Okay, we have y sine x squared plus x sine y squared. I'm going to take my derivative, left and right side. I always put that little line. I like to do that. It's just the way I do it. I have product rule here. I have product rule here. So this is like an f. This is like a g. This is a different f and a different g. All right, so let's try this left side. The derivative of a product is f prime g plus g prime f. So f prime is actually y prime times g plus, now derivative of g, be careful here. This is a chain rule. The outer function is sine. The inner function is x squared. So we have to apply chain rule here. The derivative of sine of something is cosine of that something. Then times the derivative of what's inside. Well, derivative of x squared is 2x. That's the derivative of g. But then I need to finish off the product rule, so I need to attach to that f. Okay, so that's product rule on the left side. Now on the right side, I do product rule again. This time the derivative of f is 1 times g plus, now derivative of g, same sort of story. We have derivative of sine of something is cosine of that something. But now the derivative of what's inside, which is y squared, is not just 2y. It's actually 2y, then derivative of y itself, which is y prime. Now finish off the product rule, so we also need the x out front. All right, let's try and clean this up. We have y prime sine x squared plus 2xy cosine x squared equals sine y squared plus 2y prime xy cosine y squared. And now the two terms that have y primes in them are here and here. So I'm going to move them to the left side and then everything else to the right side. So y prime sine x squared. I bring over the other one so it becomes negative. And then on the right side, I still have that sine y squared, but then I need to bring this guy over. So that's going to be minus 2xy cosine x squared. Factor out a y prime. So if I factor out a y prime on the left side, what will happen is, kind of cheating here a little bit. Oh, man. What's still cosine? So if I pull out that y prime, that's what's left. So I finally get y prime equals, divide through by both sides by all that stuff in parentheses. And all over sine x squared minus 2xy cosine x squared. Be careful, you cannot cancel these, okay? Those don't cancel because you have two terms in the denominator, so you are not allowed to do that. Okay, let's verify this answer here. There we go. Sine y squared minus 2xy cosine x squared. Yep, and then over sine x squared minus 2xy cosine y squared. So, wait a minute, cosine, did I write that down wrong? Oh, yes, I did. Thank you. I'm glad I accidentally wrote down. That was y squared that I divided through by. Y squared. Like that. All right, next problem. So we're trying to find the derivative here. All right, on the left side, I have a chain rule. I have square root of something. So derivative of square root of something is 1 over 2 times the square root of that something. Now chain rule says now derivative of what's inside. So I do these term by term. Derivative of 3x is just 3, plus the derivative of y, which is y prime. Now that's the derivative of the left side. The right side, derivative of 3 is 0, so I don't need to put anything. And then here we have a product rule. So we've done it, hopefully, enough of these. Derivative of x squared is 2x times the second one there, plus derivative of the second one, which is 2y, y prime, times the first one, which is x squared. So now what we want to do is we want to try and get our y primes by themselves. Notice here, though, that we got this y prime on the left trapped inside of parentheses. So what we're going to need to do is distribute this through. So it's going to be like this. 3 over 2 square root 3x plus y. And then when I distribute to the second one, I get plus y prime over 2 square root 3x plus y equals the right side, which is 2xy squared plus, let's see, 2y prime x squared y. Now I can actually see I have two terms with y prime in them. So I will have, on the left side, y prime over 2 square root 3x plus y. I'm going to bring over the other one. So 2y prime x squared y. And then equals, I had the 2xy squared on the right. I bring over that other thing. It becomes minus 3 over 2 square root 3x plus y. On the left side, I can factor out y prime here, y prime here. If I do that, I'll have y prime, and what will be left will be 1 over 2 root 3x plus y minus 2x squared y. And then on the right side, just leave this 2xy squared minus 3 over 2 root 3x plus y. All right, when I divide through now, I get y prime is equal to 2xy squared minus 3 over 2 root 3x plus y. That's the right side, and then divide through by what's in parentheses there. And let me change the order. 2x squared y plus 1 over 2 root 3x plus y. I have y prime isolated, so this is right, but I doubt that the book leaves it this way. They probably clean this up. So let me take a look at how much cleaning up they do of this. All right. So they cleared fractions. So let me just get you to there. What we're going to do here is we're going to try and get rid of this denominator that we have in both of these. So to do that, I'm going to come in here and I'm going to multiply the top and bottom of this by 2 root 3x plus y and 2 root 3x plus y. And when I do that, I'm going to have to distribute that through here and through here and then through here and through here. Okay, so when I do my first distribution in the numerator, I get 2xy squared times 2 root 3x plus y. That's the first distribution. Now the second one, the yellow and the blue cancel completely, so I'm just left with minus 3. Now on the bottom, same sort of thing happens. I get negative 2x squared y, but then times 2 root 3x plus y, and then when those things cancel in the second distribution, I just get plus 1. And notice that this 2 and this 2 would come together to give you 4, and then this negative 2 and 2 would come together to give you a negative 4. So now let me see if that's what we had there. Oh, no, I didn't want that. Okay, so 4xy squared square root, so this would become a 4xy squared square root, and then minus 3. Now on the bottom, they have the 1 in front, so this 1 they put in front, and then this became the minus 4x squared y. That's it right there, and then with that root attached to it. So as you can see, we get the same answer. Close some of these out. All right, I need to do number 7, but I need to get rid of all this work, so let me do a quick, oh, that didn't work. There we go. Okay, so for this one, again, we're going to do implicit differentiation. On the left side, notice I have chain rule. I have square root of something. So the derivative of the square root of something is 1 over 2 square root of what's there, then times the derivative of what's inside. Now, derivative of what's inside is a product rule, right? We've got product in there. The derivative of x is 1 times the g plus derivative of g, which in this case is y prime, times the x. So I'm done with the left side, equals derivative of 5, which is 0, and then on the right side again, product rule. So 2xy plus y prime x squared. We have to do the same sort of thing we did earlier here with this because it has 2 terms. I'm going to have to distribute this thing through to both. So I'll be at y over 2 square root xy. And then I'll have plus y prime x over 2 square root of xy equals 2xy plus y prime x squared. Now, I think what I'm going to do now, just to show you, we could multiply through by the LCD right now. If you don't have to wait till the very end. So I can multiply both sides by 2 root xy. 2 root xy. And what happens is when I distribute here, it cancels out. So that gives me y plus y prime x. And then on the right side, let's see, here to here, we get 4xy root xy. Then we get plus 2y prime x squared root xy. Get my y prime terms by themselves on one side of the equation. So y prime x minus 2y prime x squared root xy equals 4xy root xy. Bring that other term over to the other side, which was minus y. I'm talking about that one. Factor out a y prime, and then divide through by what was left. So 4xy root xy minus y all over, let's see, what was left over here, x minus 2x squared root xy. All right, I think I'm happy with that. Let's see what they've got. Which one was it, this one? I wonder if they went to rational exponents. Oh, that looks pretty good. Let's see. Well, it's kind of hard for you to see that. 4xy root xy, that's this minus y, and on the bottom x minus 2x. Okay, yeah, we got the same thing. All right, quick break for me. All right, number 8. If f of x plus x squared and then f of x to the 5th equals 34, and they give you f of 1 equals 2 and f prime of 1 equals, find f prime of 1. What we're going to need to do is first find, what is f prime of x. Basically, everything you see here, all the f of x are really like y's. And so when we take, if you look at this as a y and that's a y, we're doing implicit differentiation, but instead of saying y prime, we're going to say f prime of x. So let's take derivative of this. F of x to the 5th power, this equals 34. Yeah, okay, so let's do derivative, implicit differentiation. So here we go. First of all, what is the derivative of f? Well, it's f prime x. All right, and then we say plus. Now in this one, we have a product rule right here. So we have derivative of x squared, which gives us 2x, times f of x to the 5th power, plus, we're doing product rule, derivative, okay, we have something to the 5th power. So we have 5 times that something to the 4th power. Then chain rule says now derivative of what was in there. Derivative of f of x is f prime of x. And then finish off the product rule, put x squared. And then notice the other side of the equation equals derivative of constant, which is 0. So now what I'd like to do is figure out what's happening at 1. So let's replace all our x's at 1 with 1s, because that's what this is right here. We want that. So this means that f prime of 1 plus 2 times x is 1 times f of 1 to the 5th power plus 5 times f of 1 to the 4th power times f prime of 1 times x squared, which is 1 squared, which is 1, must equal 0. Now, what is f of 1 in the problem? They say f of 1 is a 2. So everywhere I see an f of 1, I'm going to replace it with a 2. So I've got f prime of 1 plus, let's see, 2 times 1 is just 2. So 2 times, now here, f of 1, that's a 2. 2 to the 5th power is 32. So 32 plus 5 times, now here again, that's a 2. 2 to the 4th power is going to be 16. So 5 times 16. And then times f prime of 1, I don't know what that is, and then times 1, and then equals 0. So now I need to multiply some things together. I've got f prime of 1, which is what I'm trying to find, plus 2 times 32, which is 64, plus 5 times 16, which is what, 80. Let's see, 80 f prime of 1 must equal 0. So what I'll do now is I'll try and get my f prime of 1s by themselves. So here are the terms right there, which means I'll subtract 64 on both sides. And notice if I can put these two together, that's like 1 f prime of 1 plus 80 of them. So I have 81 f prime of 1 equals negative 64. And then if I divide both sides by 81, then I get f prime of 1 equals negative 64 over 81. And I don't know if they want that as a decimal, but let's take a look. Make sure we got this right here. Can't see that. There we go. So f prime of 1 equals negative 64 over 81. Okay, use implicit differentiation to find the tangent line to the curve at the given point. So we've done this before. We know that we're going to, at some point in this problem, use y minus y1 equals m times x minus x1 because we want the equation of tangent line. The m is actually our y prime, and it's at the given point, 4, 7. So it's because this equation cannot be solved easily for y, I will use implicit differentiation on this equation right here. Derivative of x squared is 2x. I have product rule right here, so plus derivative of 2x is 2 times y, plus product rule here, derivative of y is y prime times 2x. Now I move on, minus derivative of y squared, which is 2y y prime, be careful with chain rule, plus derivative of x, which is 1, and then equals the other side, which is 0. I have my y prime terms, 2y prime x minus 2y prime y. Those are the two terms here. And then I'll move the other two to the other side, or actually, yeah, I have 3 terms to go to the other side. So negative 1 minus 2x minus 2y. And then I will factor out the y prime on the left side, which gives me y prime. What was left, I'll divide both sides by. And what was left when I pulled that y prime out on the left was a 2x minus a 2y. Okay, so that is the derivative. Now, what I want to know is what's happening at the point 4, 7. So I'm going to replace all my x's with 4s and all my y's with 7s. And that should give me the slope of my tangent line. So the slope of my tangent line will be negative 1 minus, let's see, 2 times 4, which is 8, minus 2 times 7, which is 14, all over 2 times 4, which is 8, minus 2 times 7, which is 14. So let's see, numerator, we get negative 23. Denominator, we get 8, take away 14, that's negative 6. So we get 23/6. That's our slope. So now we're ready to use our equation up here. So we get y minus y1 in our problem is 7 equals 23/6 x minus x1, which is 4. That should be it right there. That is the equation of tangent line. That is tangent line to that curve at that given point. Checking. Okay, there it is right there. Matches up exactly with what we had. And then they actually distributed this through here and here, and then combined this, added 7 to both sides, messed around with fractions. Got that. All right, same idea. We want to find the equation of the tangent line. It's just the differentiation that's going to be weird here. So I'm taking the derivative of this implicitly. So what is the derivative of x to the 2/3? Well, it's 2/3 power rule, x to the negative 1/3. And then be careful, plus, now y to the 2/3, same thing, 2/3, y to the negative 1/3, but then you have to take derivative of y itself and tack it on to the end there. So we'll have our times y prime. And then that's it for the left side, equals derivative of 4, which is 0. So now I will isolate the y prime term. That means I'm going to move the x term to the other side, which makes it a negative 2/3 x to the negative 1/3. And then I will divide both sides. So y prime equals negative 2/3 x to the negative 1/3 over 2/3 y to the negative 1/3. This and this cancel, leave me with a negative 1, so I'll just put a negative out here. X to negative 1/3 on the top really means, to negative 1/3 on top means I can drop it down. Y to the negative 1/3 on the bottom means I can bring it up. So this becomes y to the 1/3 over x to the 1/3. I wrote my fractions different there. It's kind of weird. I've always done that. So both of these mean cube root. So this is cube root of x of y over x. So that's what we got, negative cube root of y over x. Now what we want to do is we want to plug in our value. Oh, nice. So look at our x and our y value. X is going to be replaced with what looks like, can't tell what that is, -3 root 3, and then the y is going to be replaced with 1. So here's what we've got. The slope of our tangent line will be equal to negative cube root of the y value, which we said was 1, over the x value, which is -3 cube root 3. That's our slope. And then we go ahead and we plug that into our formula. Let's see what they do, because it's kind of ugly. See how much cleaning up they do on this. Okay, well, I see what they do. So this is, let me try and clean it up for us. All right, this is equal to negative, now look at this cube root of a fraction, you do the cube root on top and bottom, but the cube root of 1 is 1. And then on the bottom, what I'm doing is the cube root of 3 times the square root of 3. And I can work with that. Let me just show you what that is and do that on the side here. What is this part right here? So that is the same as, I'll do it right here. It's the cube root of 3, the cube root of the square root 3. So that's 3 to the 1/3 times over here we have 3 to the 1/2 to the 1/3. Because square root means 1/2 and cube root means 1/3. I can multiply these and get 1/6. And then when I add these together, when I multiply these two, I add the exponents. So this is going to be 3 to the 1/3 plus 1/6, which is equal to, we have to get a common denominator, so I multiply top and bottom by 2 here. So I get 2/6 plus 1/6, that's 3/6. That's 3/6 is 1/2. So that's just square root of 3. Wow, that's a very complicated way of saying that. So this is equal to -1 over the square root of 3, which is the same as negative root 3 over 3. That's just rationalizing the denominator. So let's see if they've got that. Yeah, they didn't even rationalize it. Where's their negative? I'm not quite sure why they lost their negative. I believe that might be a mistake. Oh, wait a minute, hold on. It was negative, oh, this right here. I forgot my negative in here. That was a negative right there, which means that this was negative, and then that was negative, and that was negative, and that's negative. And so when you bring in this negative, it becomes a plus. So 1 root 3 over 3. There we go. And now you can see that they just use that slope, and then they plug in their y1, their x1, and you're done. All right, on number 11, we're being asked to find the second derivative of this, and second derivative of y. So we're going to use the implicit differentiation here. Let me go ahead and take derivative. Derivative of 2x squared is 4x. The derivative of y squared is 2y prime, using chain rule there, and equals derivative of a constant, which is 0. And then I'm going to need the derivative again. So let me go ahead and just do that now. Derivative of 4x is just 4. And then on the second term, we have a product right there. So we're going to have plus the derivative of 2y, which is 2y prime, times the other function there, y prime, plus the derivative of y prime, which is y double prime, then times the first one, which is 2y, and then all that equals 0. So I use product rule there to get those terms. Now, because my answer right now, okay, has the y double prime, which is what we're trying to find, I'm happy, but I also have a y prime in here and a y prime, and we would like our y double prime to be in terms of just x and y, not y prime also. So what I'm going to do is I'm going to take my equation here, I'm going to solve it for y prime. So to y prime, I'll leave that on one side. I'll take the 4x to the other side. Then I will divide by 2y. And that gives me negative 2x over y. So that's what y prime is. And now let me take this and rewrite it. So we have 4 plus 2. Now y prime we said was negative 2x over y. And then we have y prime again, negative 2x over y. And then we have plus y double prime times 2y, and then that equals 0. So let me multiply these two together, and then I'll hit it with that 2. So 4 plus, let me see, I'll get 4x squared times 2, so that's 8x squared over, multiply the y and the y together, you get y squared on the bottom. Then plus y double prime times 2y equals 0. Okay, let me isolate my y double prime. So I will take the 4 plus 8x squared over y squared to the other side. So I'll have y double prime times 2y equals negative 4 minus 8x squared over y squared. I will now divide both sides by 2y, 2y, 2y here. And that will result in the left side will cancel. So I have y double prime equals negative 2 over y, and then minus, let's see here, 4x squared over just y cubed. So I did my 8 divided by 2 and got 4. Now that's a good answer. However, there's something kind of tricky in here that we're going to notice. The only way to notice is try and combine these two fractions on the right-hand side together by getting a common denominator. So let me put y squared here and a y squared on top, multiplying that. Okay, so I can get a common denominator. And now I get y double prime equals negative 2y squared, then minus 4x squared all over y cubed. And then notice this is the tricky part. Factor out a negative 2 out at the top, and you get y squared plus 2x squared, and then over my y cubed. And then if you look at this, y squared plus 2x squared, go back to the original problem. Y squared plus 2x squared must equal 7 in order for this equation, this equality to work. So I can just replace that with 7. So I get negative 2, then this will become times 7. So that's just a negative 14 over y cubed. And that's the cleanest version of the derivative, second derivative, I should say. All right, we're going to do the same sort of thing for this one. So first things first, I'm going to take a derivative. So derivative of 5x cubed is 15x squared. Derivative of 3y cubed is 9y squared, then chain rule, be careful, times y prime, that equals 0. Let me go ahead and take derivative again, because I need y double prime. So this is 30x plus, now here we have product rule right down there. So the derivative of 9y squared is 18y times y prime, then times the other one, y prime, plus derivative of y prime, which is y double prime, times the first one, which was 9y squared. That must equal 0. And again, we run into the same issue. I have y double prime here, but I also have y prime and y prime in here, so I want to get rid of those. So I'm going to take this equation here. I'm going to solve it for y prime. So we have 9y squared y prime equals, take that 15x squared to the other side, negative 15x squared. I'll divide through by 9y squared, so negative 15x squared over 9y squared. And let's go ahead and divide or reduce the fraction there. 3 goes into both those. So negative 5x squared over 3y squared. This is our derivative. And so now I'm going to rewrite all of this. So this will become 30x plus 18y times y prime, which was negative 5x squared over y squared, 3y squared, times that again, negative 5x squared over 3y squared, and then plus y double prime times 9y squared equals 0. All right, let's go ahead and multiply these two together here. If we multiply those two together, you get 25x to the 4th over y to the 4th. And then I'm going to have to multiply that by the 18y. So if I multiply this by 18y, I do 25 times 18, which gives me 450. So I have my 30x. Plus I have 450, and that was x squared on top with a y. And then on the bottom I have 3 times 3, which is 9, and then y squared is y to the 4th. Oops, I forgot my x to the 4th up here. X to the 4th y. And then plus my y double prime times 9y squared equals 0. All right, fortunately for us, 450 divided by 9 is going to give us 50. So let me move down a little bit here. I've got 30x plus 50, do it this way, 50. On top I still have x to the 4th, and on the bottom I have a y cubed. So what I did is I just canceled out one y there and one y there, and left me cubed. And then plus y double prime times 9y squared equals 0. All right, let's isolate the y double prime term. So let's move those other terms to the other side. And when I do that, I get y double prime times 9y squared equals negative 30x minus 50x to the 4th over y cubed. I will now divide everything by 9y squared. And we get y double prime equals, see, I can reduce 30 and 9 because they both have 3 goes into them, so it's negative 10x over 3y squared. And then the other fraction, I have 50x to the 4th over 9y to the 5th. Okay, so that's putting those together right there. All right, so again, what I'm going to do is get a common denominator. So what I need to do is I need to introduce a 3y cubed here and a 3y cubed there. I'm going to multiply. So we get y double prime equals negative 30 xy cubed, and then minus 50 x to the 4th over 9y to the 5th. And then notice on the top, we had our original equation here. What was it? 5x cubed plus 3y cubed. Notice if we pull out a negative 10x, we'd be left with 3y cubed plus 5x cubed all over 9y to the 5th. And then this, from the original problem, that has to be equal to 1. So since that's equal to 1, this is negative 10x over 9y to the 5th. Okay. And that is our second derivative right there. All right. So you got to be careful here trying to find that the original equation was somewhere in the derivative, second derivative. It won't always be that way, but for most of the problems you're going to see, it's probably going to be hidden in there. Quick little pause. Okay, for this one, you have the curve with this equation. It's called a Campbell of exodus. Find the equation of the tangent line of this curve. So we've done this before, finding the equation. We need to find the slope of the tangent line, which means we need to find y prime. So let's go ahead and work on this. Let's try and find y prime. Let me zoom in a little bit. Okay, so look at this, and I'm going to do implicit differentiation. Get 2y prime using chain rule on the left side. Get 20x cubed minus 2x. And now to solve for y prime, I divide through by 2y, and that just becomes 10x cubed minus x over, I'm reducing everything by 2. This. Now, if we want to know what's happening at the point -1, 2, I know that then that the slope of my tangent line will be 10 times x, which is -1, cubed minus x, which is -1 all over, my y, which is 2. So we get, let's see, -10 plus 1 over 2, which is -9/2. And then you have the equation, the general formula we use, which would be y minus y1 equals m times x minus x1, which would be minus a negative. So that should be it. Let me go ahead and go all the way with this. Distribute 9/2 through, -9/2 through. Let's add 2 to both sides. And when I add 2, it's the same as adding 4 over 2. So we can have a common denominator and add those together. And then that's y equals -9/2 x and minus 5/2. So we could plot this line. -5/2 is -2.5. And try and figure out which of these looks like the right one. We'd actually need a better graph. You'd have to be able to graph that. Let me see what else they have here. Here's our answer right here. There it is, right there. This is what we did up there. Here's the curve now. There are different ways to get a computer to graph this, and I ask that what you do is maybe go to a website. Boy, there's all sorts of, let's try Wolfram Alpha, in case you've never seen this before. How to graph something like that. Wolfram Alpha. And go here. And then the equation I'm going to type in was this one right here. Y squared equals 5x to the 4th minus x squared. Y squared equals, so I go y squared equals 5x to the 4th minus x squared. Let me just double check that. Yeah. Okay, so I'm just going to type that in and hit equals and hope that I get a graph. There we go. That's it right there. It's what we call the implicit plot. And yeah, I can't zoom in on that, but that's it. So that's one way you can do that. And you could, you can actually go back and change these. Like you can graph anything, like normal functions. They don't have to be implicit. So like y equals that. This should be a 4th degree polynomial. There we go. So very cool website. And is that the last one? Yeah, so that was our answer right there. Okay, that's it for this section.